All right, here's a question. We're talking about bonding, intermolecular bonding, hydrogen bonding, London dispersion forces, and dipole-dipole forces. And we need to compare two compounds. And so in the first question, they say write down the molecular formula. So tellurium difluoride would be TeF2, and nitrogen trichloride would be NCl3. So there's the two compounds. Now I'm not doing a chemical reaction between them. I'm just sort of comparing what they each have. Okay, so the second thing says indicate the types of intermolecular forces present. So tellurium difluoride is going to be something probably similar to water, because tellurium is right here, and it's in the same column as water. So it's going to be a bent molecule. So if you take a look at it, it'll be Te has 6 electrons. So 1, 2, 3, 4, 5, 6. And then fluorine has 7, and each fluorine will get stuck right in there. So there's one of them, and fluorine's got 7, right? Here's another fluorine right there, and it's full all around. So that's what tellurium difluoride would look like. And it would have, so because it's bent, it would have dipole-dipole forces. So it has those. And hydrogen bonding, there's no hydrogen, so it doesn't have that. And then London dispersion forces are dictated by how many electrons the thing has. So tellurium has 52, and then each fluorine's got 9, so it's another 18. So it's got electrons to the tune of 70. So in terms of intermolecular forces, that's tellurium difluoride. Okay, now let's look at this other one. Nitrogen trichloride, so I have a nitrogen. Nitrogen's got 5, and then chlorine slips in here, and chlorine's got 7. Another chlorine over here, and another chlorine there. One of those should have been an X. Okay, now because of these lone pair of electrons, that makes this molecule, like this one over here was bent, and that's why it has dipole-dipole forces. But this one, because of those, this one's going to have a trigonal pyramid shape. So like nitrogen would be here, the chlorines would be like there, and then one sort of at the back going down. So it'll be like a pyramid. So it also would have dipole-dipole forces. Hydrogen bonding, no hydrogen, none of that. London dispersion forces, okay. Nitrogen is number 7, and then chlorine is number 17, and there's 3 of them. So 17 times 3 is 51. Add those, you get 58 electrons. So, there, I've shown the types of intermolecular forces present. Got it. Count and show the number of electrons. Got it. Explain which substance should have the higher boiling point. Well, when you're looking at them, yeah, it's they each have dipole-dipole forces, but these ones are because the molecule is bent, and this one's because it's sort of trigonal pyramidal shape. So there might be differences there. This one has more electrons, so maybe just based on the fact that it has more electrons, maybe I would give the nod to that. So that's what you're trying to do with this question, is you're trying to sort of take a look at the intermolecular forces and see, compare the two compounds just to see which one you think would have a higher boiling point. Then the next thing you could do is do a search on it. So look up tellurium difluoride and nitrogen trichloride, look up their boiling points and see if you're close. Just based on theory, looking here, I'd give the nod to this one because there's more electrons. But there's there's something that could happen between the type of dipole-dipole forces and whether one's stronger than the other one. All right, hopefully that helps you with that question.